Hi everyone, and thank you for joining us today for our webinar, Unlocking the Potential of RTLS, Insights for Integrators. I'm Liat, and I'm the CMO of Duke, and with me here today, Michael, the Director of Business Development. I would like to draw your attention to the questions panel to in the top, right top of the screen. You can see a question mark. When you click on it, you can write your questions during the webinar, and we will do our best to answer them at the end of the presentation, in the Q&A session. So, Michael, why is it so important for integrators to understand how RTLS work?
Thank you, Liat. Well, because real-time location solution, in short RTLS, are solutions to many use cases, different needs and situations, also studies, all with the goal to improve efficiency. The integrator role is not only to install the solution, but to tailor it to the customer needs. In this webinar, we will explore RTLS in details, discover its markets, compare different RTLS technologies. As professionals, we need not to only understand technology, but also the purpose and value of it in different industries, and how to perform smooth integration. The demand for RTLS is growing rapidly. Early adopters include logistics, healthcare, manufacturing, and retail markets. By implementing RTLS, organizations can track assets, patients, workers, equipment, and in-store inventory, and with that, achieve enhanced visibility. This improved visibility allows better decision-making regarding inventory management, equipment utilization, and maintenance planning. As a result, businesses can increase productivity, reduce operational costs, improve asset and workforce management efficiency. Additionally, RTLS contributes to enhanced safety and delivers a better customer experience. As you can notice from this slide, the RTLS market is growing very fast. The compound annual growth rate is 20%. It's clear that there is an increase in the need for RTLS. First comers are heavily industrialized zones. RTLS has great potential, but implementing it has challenges. Integrating with existing platforms like ERP or WMS with vast amount of real-time data is a challenge. An additional issue is scalability, because RTLS should work in growing environments. Yet, these challenges bring innovation. With AI and machine learning, companies can make predictive analysis and make smarter decisions. With wireless and low-power sensors, we get cost-effective and energy-efficient solutions. Cloud platforms offer scalability and centralized data. With RTLS expanding to new markets, there are exciting possibilities, especially in agriculture and smart cities. By taking care of these challenges with RTLS technologies, we're not just solving problems, but creating a more connected and efficient world. Today, different RTLS technologies exist, different for indoor and outdoor location tracking. For outdoor tracking, GPS infrastructure is commonly used. However, its accuracy is limited. GPS requires visibility of at least 4 satellites to find a location, typically with an accuracy of a few meters. Bad weather impacts on accuracy and reliability. For indoor tracking, there are several technologies, including Bluetooth Low Energy, ultra-wideband, Wi-Fi using RSSI or time of flight, RFID. Most of these technologies are here for over 2 decades. UWB is a more recent one. However, this solution requires a lot of infrastructure. This infrastructure requires many beacons, prohibitively costly, depending on the size of the service area. BLE has a few meters accuracy, but requires dense beacons infrastructure. UWB provides greater precision, but its infrastructure cost is extremely high. In both cases, the need for dedicated infrastructure makes this solution non-scalable. Expanding to a new site requires installing an entirely new infrastructure, adding even more to cost and complexity. Diog has solved this issue by using the already existing Wi-Fi infrastructure in a non-intrusive manner. We do not connect to the Wi-Fi. Our technology senses the Wi-Fi beams from Wi-Fi access points without requiring network names or passwords. This enables the use of global Wi-Fi network of approximately 9 billion Wi-Fi access points, by far the largest existing infrastructure available today. With Diog, there is no need to install costly infrastructure, and scalability becomes virtually unlimited. Whether for indoor or outdoor application, our solution provides a cost-effective way to track assets accurately and efficiently. More interesting, how is it done? We combine interferometry and AI. What is interferometry? Interferometry involves the use of laser beams. The laser beams are sent to a star to measure its angle relative to Earth. In our context, a Wi-Fi access point can be compared to a star and a tracker to Earth. Why do we use interferometry? We use this technique to calculate the angle between a Wi-Fi AP and a tracker. With this method, combined with AI, we find accurate and reliable location without the need for dedicated infrastructure. How does it work? The Wi-Fi access point acts as a source of light, like a star emitting two wave beams, ray 1 and ray 2. These beams are identical, but one reaches the tracker slightly earlier than the other, depending on the angle between the tracker and the Wi-Fi access point. The tracker measures the phase difference, theta, between the two beams. This phase difference is then used to calculate the angle of departure, providing precise directional information between the Wi-Fi antenna and the tracker. Here's a step-by-step explanation of the process. The first step is phase differential measurement. An interferometer is run on each Wi-Fi access point to measure the phase differential theta between its two beams. The second step is to collect the data from the multiple APs. With 3 APs, we measure 3 phase differential, theta 1, 2, and 3, each which is MAC address, MAC 1, 2, and 3. Then the next step and the third step is the backhaul connection. It is to send the information to the cloud via a backhaul connection, and this is required for the data to arrive inside the cloud. This can be via Wi-Fi, if we know the Wi-Fi network, or via cellular connection in unknown networks, such as in shopping malls, for example. The next step is angle calculation. The calculation which is performed in the cloud. In the cloud, we calculate the angle of departure for each phase differential for theta, for actually AOD1, angle of departure 1, 2, and 3. And from these angles, we get a triangle between the 3 APs. Fifth and last step is location determination and outputs. Using the Pythagoras theorem, the precise location XYZ within the triangle is calculated in the cloud. This location data is then sent to a database or a data center, or displayed on a map via APIs, allowing visualization on a mobile device. This is an RTLS technologies comparison table. The comparison is between currently available RTLS technologies such as Bluetooth, Wi-Fi RSSI, time of flight, UWB, GPS, GPS RTK, and Diog. You can see here three columns. The first one is ubiquity, which means indoor and outdoors. The second one is about precision, in the sense of location accuracy, by example, 5 to 1 meter, below 1 meter accuracy, or 10 centimeter accuracy. And the third column is the scalability. How easy is it to scale up from 1 to 1,000,000 locations? As can be seen from the slide, BLE and UWB have low scalability indoors. You can see it from the red boxes, while the Uke has no such issue, which is on the bottom, the green box. Let's talk about a few use cases. So let's look at our first use case, an RTLS for warehouse pallet management. For example, consider a large warehouse handling thousands of pallets that need to be exported daily. Often, pallets are misplaced within the warehouse, causing forklifts to spend extra hours locating and sorting them. This inefficiency increases operational costs. Implementing an RTLS solution can significantly reduce these costs by providing precise pallet tracking. But we have a few key considerations. First, the pallet quantity. We need to know the total number of pallets because each pallet requires a tracker. Then we need know the movement frequency. Pallets are typically collected once per day at most. Therefore, tracking their exact location on an hourly basis is more than sufficient. Then we need to know the location accuracy. Since each pallet occupies a space of 1 by 2 meters, a location accuracy of 1 meter or better is acceptable. Then there's the storage arrangement. Pallets may be stacked vertically, requiring a smaller size warehouse. And followingly, there is infrastructure requirements. Most warehouses today are already equipped with Wi-Fi access points. In our case, in the Uke's case, the Uke's technology leverages this existing infrastructure, requiring minimal additional setup with a recommended spacing of 20 meters between APs. So that's 20 meters between each one of the two access points, so on the triangle actually. If sufficient, AP coverage is already in place. No additional infrastructure is needed. In cases where there are insufficient access points, the Uke second generation tags can compensate for the lack of infrastructure. This innovative approach keeps infrastructure costs significantly lower compared to traditional RTLS systems, as I showed in the previous slide. Now, we need to consider also what are the cost drivers in our use case. The primary cost driver is the number of tags required, calculated as the total number of pallets multiplied by the price of the tag per tag. The second cost driver is the infrastructure costs, and which is significantly reduced thanks to the Uke use of existing APs placements, with minimal augmentation required only when necessary. So we just reuse the current existing infrastructure, so our cost on the infrastructure is much more reduced. By addressing these considerations, the warehouse can streamline operation, reduce forklift working hours, and minimize overall cost. Let's take another use case. RTLS for forklift fleet management. For example, in a warehouse, there are several forklifts, some of which remain idle for part of the day. What can we do? Some of the forklift drivers need a break. Operating a forklift comes with significant cost. Therefore, reducing the number of forklifts required can lead to substantial savings. In a large fleet, identifying underutilized forklifts and reducing forklifts numbers result in even higher savings. What are our key considerations for this use case? First is the forklift quantity. The number of forklifts in a warehouse typically falls within a 2-digit range. Then we have the movement frequency. forklifts are constantly moving because tracking their location every second is necessary for real-time management. Location accuracy. The Uke offer location accuracy of below 1 meter. Even we can reach centimeter level accuracy, which is sufficient for precise forklift tracking. Then we have the software. We need a dedicated software solution to monitor forklift activity and measure idle time accurately. We want to reduce the number of forklifts, so we need to know when they are idle. Then there is the infrastructure requirements. Most warehouses are already equipped with Wi-Fi access points, as explained in previous slide. Now we have the cost driver for this use case also. So first cost driver in this case, I just in the pallet use case, the first cost driver was the number of tags. In this case, the primary cost driver is the software, which is typically priced based on the number of forklifts being monitored. Infrastructure. The infrastructure costs are kept minimal due to the Uke ability to use existing APs, with only minimal augmentation required if necessary. So again, the infrastructure cost is lower. As shown in this illustrative video, there are 6 original access points represented by the white boxes. So let me just run the example. So you can see there's a forklift now driving, and he's connected to 3 access points, which are the access points which are the closest to him. And when he moves from one location to another, he's connecting to other access points. In any case, there were 6 white boxes. The coverage was incomplete, so we added 3 Uke D2 tags, represented the D2 or the second generation tags, represented by the purple boxes, to ensure full coverage, enabling seamless tracking of the forklift wherever it operates. So now we have a full coverage with the white and purple boxes, and so no matter where the forklift is inside the warehouse, we will be able to track it. So that's our second use case. Okay, so when implementing real-time location systems, it's essential to follow a series of best practices to ensure success and minimize risks. Now, in the next 3 slides, I will explain about those best practices, which are very important for RTLS integrators. To successfully install RTLS, you need a strategic and methodical approach. Clearly define the use case and success parameters. This is very important. This is the first point, actually. Think about the business goals. You need to check which specific problem RTLS should solve. Is it asset tracking or employee safety or just process optimization? Prioritize use cases based on ROI and feasibility. Another point is the infrastructure. You need to check your infrastructure readiness because RTLS needs infrastructure. You need to check your network capabilities. For example, if there is Wi-Fi or Bluetooth coverage. You need to make sure that hardware and software are compatible with existing systems. Plan ahead for power and sensor placement logistics to avoid operational disruptions. Then, when selecting the technology, you need to choose the right RTLS solution that matches your use case requirements, because different technologies such as UWB, BLE, or RFID have unique strengths matching various needs. For example, do you need sub-meter accuracy or 1 meter accuracy is good enough? And also, what's your budget? The more accurate you want to go, the higher it will cost. Don't forget environmental factors like interference and physical obstacles. An additional point is the use of standard communication protocols. This is a critical step to ensure smooth data exchange between RTLS and your enterprise systems. We recommend to use supported standards such as MQTT, OPC UA, or REST APIs. Don't use proprietary protocols to reduce the risk of vendor lock-in. A fifth point is plan your solution to be scalable and easy for future expansion, because there will be growing demands and we want to avoid complicated reconfigurations. Modular architecture and cloud-based platforms make scaling up easier and enable long-term flexibility. Then, make data integration simple. Make sure the RTLS generated data is without errors and integrates smoothly into existing systems like ERP, WMS, or MES. Middleware or integration platforms such as Zebra Savannah or UbiSense SmartSpace can automate data mapping and transformation, making sure consistency and actionable insights are kept. An additional point is to ensure robust data security, and this is critical because protecting sensitive location data not only maintains trust, but also ensures compliance with regulations such as GDPR and HIPAA. This can be achieved through encryption of data, both in transit and at rest, along with implementing user access controls and audit trails. An additional point will be thorough testing and validation of your installation. Thorough testing. Identifying issues early reduce integration risks. So testing RTLS functionality in a simulated environment and validating its performance under real-world conditions are crucial steps. We recommend to do a pilot. Pilot programs should be conducted before full-scale deployment to iron out potential issues. Training stakeholders is vital to ensuring that users can effectively leverage the RTLS systems. You need to understand for the customer operating RTLS systems is operating an advanced system. So you need to train both system administrators and end users along with clear documentation for troubleshooting, and this will empower our users to fully benefit from the system. An additional point is continuously monitoring and maintenance. These are necessary for sustained performance. By monitoring key performance indicators such as accuracy and uptime, scheduling regular maintenance, using analytics to identify areas for improvement, RTLS system can remain optimized over time. An additional point is the collaboration with vendors and partners. This is another critical factor, as vendor expertise can reduce integration complexity and expedite deployment. Engaging with experienced RTLS integrators, leveraging vendor tools and documentation will enhance the integration process. So you need to have good partners. It's important to maintain flexibility. This is the last point I will mention. And this is because businesses' needs and technology evolves. So designing integrations that are modular and upgradable ensures that RTLS systems can adapt to future requirements. You need to keep flexibility. By following these steps, your organization can unlock the full potential of RTLS while avoiding common pitfalls. You can minimize integration challenges, maximize ROI, and position yourself for long-term success with RTLS solutions. Okay, let's wrap it up. So, what are the actionable insights for the RTLS integrator? Number one is to know your customer. What does the customer want? What does he expect? The first step is to truly understand your customer needs. What outcome does the customer want from the RTLS solution? What are the key performance indicators, KPIs, for success? We recommend to ask the following question. What is the purpose of installing RTLS? What specific use case is being addressed? What assets need to be tracked? Are you tracking movable objects, fixed assets, or both? What level of accuracy is required? Do you need high precision, or is a less accurate location sufficient? Do you need different levels of accuracy in different sections of the service area? There's no silver bullet in RTLS. You may need one solution in one area of the warehouse and another solution which is less accurate in another place of the warehouse, and of course this will impact on cost. So there are some areas which are more critical than others in terms of accuracy. How often do you need location information? Should updates be provided every second, minute, hour, or on a different schedule? Then there are questions about the site. Does the site already have infrastructure? Because this is, as we saw, an additional expense. And the question is, what existing infrastructure is in place? Is it Wi-Fi? Are there sufficient number of access points? Is the current infrastructure sufficient, or is augmentation needed? Does the infrastructure need to be expanded or upgraded? It means, do you need to add access point, or do you need to exchange the access point to other access points? Is scalability required? This is an important question, because if customer has multiple sites, then he will need a scalable solution. And not only, but are these sites similar one to the other? Because if they are different in layout and size, maybe he needs different solutions. What kinds of software needs to be integrated? Do we need to integrate with existing software, or will a custom solution be required? How does the customer want to view or access the data? This will also impact on the software, because he will have to choose between existing software or a specific software that is developed for his purpose. How will accuracy and scalability impact on costs? Finally, at the end of the day, the customer needs to check his ROI, or his return on investment. So he needs to consider the cost, and what are the cost considerations based on accuracy and scalability is a very important question, because the more accurate you go, the more cost you have, the higher the cost is. How to provide the best solution would be the last question. Providing the best solution requires experience in RTLS installation, as you saw from the best practices. You need to understand a lot of points here, but don't worry, we're here to guide and support you every step of the way. After completing a few installations, you will be well equipped to handle RTLS projects on your own. That's all, folks. And let's see what questions you have.
Thank you so much, Michael. That was really great. We have a few questions here, and of course, you're welcome to add more questions as we speak. Can the Yoke work with another RTLS solution that a customer already has?
The Yoke technology is actually a solution that's a technology. So it's a different technology than Bluetooth, ultra wideband, Wi-Fi RSSI, and it's like a sandbox. So you can add the Yoke technology to Bluetooth technology and create hybrid solutions. So or to UWB. So yes, we can combine the Yoke technology to other technologies. There are even already solutions on the market which are combining Bluetooth and UWB. Those are hybrid solutions, and they give the possibility to get the best accuracy out of the solution. So you get an accuracy from the BLE, you get an accuracy from the UWB, and you can compare those accuracies and then get the best solution out of it.
Thank you. What is the industry best suited for the Yoke solution?
Well, the Yoke solution is actually a horizontal technology. So this horizontality, applies to many verticals. We can answer logistic markets. We have solutions for the logistic markets, for manufacturing, retail, for the medical market. So you can take the tracking location solution to a lot of verticals. It's technology, actually.
In the short video you showed, could you tell us some more about the purple boxes that you showed, like about the price? Do they involve IT? There's more to the question, but I'll go one by one.
Okay. The purple boxes are actually the second generation of the Hugh tag, and those tags have a dual purpose. They could be a tag, so they could track location, but they could also be an anchor, and so they could augment the infrastructure. So if there is not enough Wi-Fi access points in the warehouse, as I showed on the slide, we just put those D2 tags as augmentation. Their price is the same cost as a tracker, so this keeps the infrastructure at a very low and attractive price. In fact, the second question was,
do you have to involve IT?
Okay. Actually, not. The installation of those D2 access points is very simple. You just have to add them to augment the coverage of the Wi-Fi. So you just need to put them in the right places, but there is no connection to IT or no configuration. Just put them on the wall.
And what is their contribution to the accuracy?
Well, as I've shown before, the triangle, which gives us actually the location of the tracker in the middle of the triangle, or somewhere inside the triangle of Pythagoras, between every two APs was 20 meters distance to get an accuracy of approximately up to a few centimeters. The closer those access points come to each other, the better the accuracy. The further the access points go from each other, or the more distance they are from each other, the lower the accuracy. So if you put a lot of infrastructure, you will get a very high accuracy. And so adding D2s, adding those anchors will increase the accuracy of the solution.
A couple more right now. What are the logistics issues you need to account for when deploying an RTLS solution?
Well, actually, many times you go to a site that you need to install an RTLS solution, and it's a production site. So in most cases, it's a production site. It's constantly working, and you need to deploy their infrastructure, and then you need to stop the production, and this is a big problem sometimes. So you need to prepare yourself to do the installation of the infrastructure in the best way to avoid interrupting or disrupting the production. And the second thing is that you also need to think about the use of the trackers. When you're going to put a lot of trackers inside a warehouse, maybe thousands of them, then you need to do it in a way that the customer, it will be easy for him to place the tracker on the item he wants to track, and then to move it from one item to another item, and then to reconfigure it, etc., etc. So the whole process needs to be prepared well in advance, and thinking about the logistics issues of installing the RTLS.
What would you consider the biggest challenge in RTLS implementation?
Well, that's a very good question. So I will go here to the most important question, and that's the ROI question. Finally, at the end of the day, any customer who purchases an RTLS solution for his needs, he wants to save money. it's all about efficiency, and he's not going to pay more for the RTLS solution than he's going to save money. So it's very important when you prepare a solution for a customer that you will be within the budget of what he can spend on the RTLS solution. And it's always a trade-off. So the customer has a need, but he also has a limit of the budget. So you need to find something which comes close to the budget and which is good enough to give him a technological answer. And that's the biggest challenge, to really give the right solution and also at an attractive price.
Okay, thank you for your questions, guys, and that seems to be the last question. Thank you very much, Michael, and you will receive the recording in the mail, and please feel free to ask any further questions. You have Michael's contact here, and thank you, and have a good evening.
Thank you very much, Liat.